The universal gravitation equation is used to calculate the force of gravity felt between two objects separated by a distance. The variable f, sometimes written with the subset g, is used to represent the force of gravity between the two objects as measured in newtons. The variable capital G represents the gravity constant. This is a value that remains unchanged no matter where these objects are in the universe. Capital G will always be equal to 6.67 times 10 to the negative 11 Newton times meters squared divided by kilograms squared. These units are set up so that meters and kilograms are canceled out at the end of the calculation. The variable m sub 1 is used to represent the mass of the first object as measured in kilograms. The variable m sub 2 is used to represent the mass of the second object, also measured in kilograms. The variable d is used to represent the distance between the two objects as measured in meters. We can describe the universal gravitation equation visually by drawing the two objects as circles, where the size of each circle is proportional to the mass value of the object. The distance between the two objects is drawn from the center of mass of the first object to the center of the mass of the second object. Now let's use some algebra to rearrange the equation in order to solve for different variables. We'll start by multiplying both sides by distance squared in order to remove the fraction from the equation and to move the denominator to the left side. This gives us fg times d squared equals capital G m1 times m2. We'll use this as a jumping off point to then solve for m2 and distance. m2 will be found by dividing both sides by capital G and m1. This gives us the new equation of m2 is equal to the force of gravity times the distance squared divided by the universal gravitation constant times the mass of the first object. Make sure your order of operations are correct when plugging this into your calculator. To do this, simply surround both sides of the fraction with parentheses or simply by multiplying both values out first before doing your division. Keep this equation and you can then use it to solve for the mass of an unknown object. Next, we'll solve for distance by dividing both sides by f sub g. This gives us distance squared is equal to capital G times m1 times m2 over the force of gravity. However, we do not want distance squared, we want distance. So to remove the square on the distance variable, we'll take the square root of both sides, giving us the equation distance is equal to the square root of g times m1 times m2 over the force of gravity. Make sure that the multiplication in the numerator occurs before the division and that the entire equation is square rooted at the end.